Welcome back to another video for our SHSAT 2023 Form A. Now in this video, we're going to go from 71 all the way to the end of the video for all the questions all together. Now let's take a look at this one. Question number 71 says, if n is an odd integer that is less than negative 3.25. Now in here, up to this point, we should be starting to draw a number line if you feeling this is more convenient for you. Now, a negative 3.25 is going to be somewhere right here, which is on the left side. It says, what is the greatest possible value for n? Now, n is something that is an odd integer that's less than that. So that means I'm going to find something that is less than that. That means on the left side of the bar of negative 3.25. So let's take a look. Now we have negative 1, which is somewhere right here. Negative 2, which is somewhere right here. Negative 3 is also somewhere right here, but negative 5 is the only one that actually is on the left side, since this is the only number that is greater than 3.25 without the negative sign. So that is how we choose answer D. Let's take a look at question number 72. A swim instructor used the box plot below to display the distribution of the ages of the student who signed up for the swim lessons. Now in here, the title says students' ages. That means this is going to be talking about 5 years old, 6 years old, 7 years old, all the way to 13 years old. The question says which statement about the distribution is going to be true. So we're going to analyze all of this. First thing, when there is a box whiskers, this is called box whiskers, and each box right here is actually representing 25% of the entire population. Each one is going to be 25% of the population. Again, this one is 25% of population. Now in here, these are talking about percentages of people. So that means there are 25% of people, regardless what is the total of the people. 7 to 8 years old is 25%, which is one check. And that is called the first quartile. And then in here, our second box is boxing from 8 to 9. That is our second quartile. So the first quartile, second quartile. And then the third box is going from 9 to 10. So I have our third quartile. And then the fourth one is right here. It's been a little bit wider, but it's okay. It's just saying that we have less people on each of these ages, okay? But 25% of the total people spending from the age 10 all the way to 12, this is called the fourth quartile. Now, all of these are actually quartiles, interquartile. We use this to describe each box, okay? So this is going to be our four interquartiles. First thing, it says the data contains an outlier. Well, we actually cannot tell because we may be having some extent to all of these box whiskers so that we know that these are actually having outliers. Because I have a data that is super extremely far away from anything, that is what we call an outlier. But in here, I don't see that any of the things is being stretched out because they're very centered, very gathered together from 7 all the way to 12. So I don't think this is going to happen. Let's take a look. F says that approximately half the students are exactly 9 years old. Well, you cannot actually say that half the students are exactly 9 years old because when we look at it, half the student is actually the middle of the 25%, or maybe the first 50%, or maybe the last 50%. That is how you describe 50% of people, which is half of the population, right? Half of the students, right? But that is not the case because we said exactly 9 years old. That means specifically in here. We don't know because we only have 25% on the left side of 9 years old and also the right side of 9 years old. That means 50% of the people is spending from A all the way to 10 years old. So this is how we read 50% of people. That's not exactly 9 years old. That's not super accurate. Now again, if the answer is not accurate, we cannot do that. So again, exactly 9 years old is not going to be correct. Let's take a look at the next one. It says approximately 1/4 of the students are at least 10 years old. Now here comes the keyword says at least 10 years old. That means I'm going to start from 10 years old and then take a look at everybody who's on the right side. That is how at least is, right? At least means the floor. It's not a ceiling, it's a floor. So that means that we start at there. So we start at 10 years old, we actually see 25%. Well, actually, hold on, 25% over here is actually 1/4, isn't it? So I believe this will be a good answer. Let's double check on answer H to see if that is going to be correct. It says the interquartile range is 3 greater than the range of the data. Now again, the interquartile range is just the middle 2, which is the middle 50%. So in here, we're going to have the yellow. Let's go ahead and box up the yellow. these are going from 8 all the way to 10. So this interquartile range is 2. Interquartile range is 2. What was that? I go from 8 to 10. So interquartile range is actually 2. Let's take a look at this one. And then it says it's greater than the range of the data. Okay, the data is 7 all the way to 12. So what is the range of the data? The range of the data, the entire data is 12 minus 7, which is going to be 5. Now again, the interquartile range is actually just 2. Well, we compare 2 and 5, great. The difference is 3, but it says 2 is greater than 5. Well, that's not going to be possible. 2 is not greater than 5, so double confirm that this is wrong. So the answer is just G. Let's take a look at 73. Now it says between which 2 consecutive integer? Okay, we have a vocabulary consecutive. What's actually here means one right next to another. So 1 next to another. Okay, so it's going to be the fraction 29 over 7. That means we have to do a simple division, thinking about, what is 29 divided by 7? Let's take a look. We have 3 times 7 is 21, and then 4 times 7 is 28. Okay, so we have a remainder of 1. So in here I have 29, 28, and a remainder of 1. This remainder is A, so it's not going to work. Let's take a look at 5. 5, 35. Well, we don't have because that's going to be not okay. So in here, we should have between 4 and 5 because I have 4, remainder 1. So it's a number between 4 and 5, just like that. We have to try out some numbers to see that where is it approximately going to be. We know that. Double check by checking 4, I have a remainder of 1, or remainder 1. I check 5, and the 5 is not going to be working, so that means I have to be somewhere between 4 and 5, just like that, between 4 and 5. Wonderful. Let's take a look at number 74. Now here we have a customer wants to buy a pair of hiking boots. The original price is going to be $85.75. The store is offering a 50% discount on the boot purchase. And then the customer is having coupon for an additional, again, pay attention to the word additional 25% off the sales price. So that means I'm going to do this first. I'm going to do the discount second. And then I'm going to do a coupon discount again on the off price, on the off price. The last one is going to be the tax rate. It's 8.5%. So this is going to be something that is add on. That's step number 4. What is the final cost of the boots, including the tax and the nearest cent? So in here, I'm going to move on to calculation. Now, in our method of calculation, taking a percent off for a coupon means I'm actually taking 1 minus that amount of percent. So I should have 85.75 and times 1 minus 15%. Now, that means I'm actually taking a 0.85 as a multiplication. That's our first discount. After that, I'm going to go ahead and use that. Additional 25% off. So I'm going to times again 1 minus 25%. So based on that, I'm actually timesing 0.75. Again, that's my second discount. And the last one says the sales tax is going to be 8.5. So I have a tax rate. I'm actually paying extra. So in here, I'm going to have 1 plus 8.5%. So based on that, I'm going to have 1.085. Be careful with the percentage. We're moving 1 decimals away. So I have a 1.085. So based on that, let me rewrite this equation. We have 5.75 times 0.85 times 0.75 and times 1.085. So in here, this one is the one with the most decimals. So if you have time, this is why in our SHSAT, we always encourage you to use as much of the time that you need on the heavier calculations. But the rest, we got to find the tactics, and then our techniques of finding the answer. Let's take a look at this one. We're going to times 0.85. We're going to times 0.75 and times 1.085. And our final answer is just that. And here our answer is 59.31. So 59.31. And then we choose the closest answer in here, 0.32. Now, the only reason it caused it here to have a 1% different out of the 1 cent different is going to be because that people round it differently. Okay, it's okay to round it differently because some people might solve the first step, re-round it, and then solve the second step and then round it, and then solve the third step and then round it again. So if you do have a calculator, I suggest you to write out the whole entire equation at one entire step to find out the most accurate answer. But in here, because if you are actually solving it step by step, it's perfectly okay to round at each step. So that's why we're going to have the 1 cent different. 1 cent different is perfectly okay. So this is just 1 cent difference. It's perfectly fine. Okay, so let's take a look at the next one. Number 75. Sheila is saving money for her summer vacation. She started summer with a balance of $90. Okay, she already has it. So this is what a balance stands for. You already have the money. And plans to save 15% of her earning each week. Okay, this is going to be happening every single week. Be careful. She earns the same amount each week. After 12 weeks, Sheila saved a total of $472.59. Again, this is the amount of time. 12 weeks already passed. How much money does Sheila earn each week? Because of that, I'm looking for how much she's earning. So therefore, I'm going to set up this equation correctly. First thing, I have the total. Based on that, she is starting with the $90, which is the balance. And then add on with the 15% times the amount of each week. And then how many weeks happened? Oh, now I have 12 weeks happened already. So in here, we're plugging in. We plug in 472.59 coming from the total is equal to the $90, which is coming from the balance. I'm going to add 15%. Oh, 15% in decimal, just 0.15. Great. And how much she earned in a week? I don't know. Let's go ahead and put a question mark. That's what we don't know. And how many weeks just passed? Oh, 12 of them. Great. So in here, we can actually do a step-by-step calculation. In here, first thing, we know this is the 190 plus. Oh, what's 0.15 and 12 going to be merged into? Let's take a look. 12, 0.15. 2 times 5 is 10. 1 times 2 is a 2. Adding with that, we come with a 3. 1 times 5 is a 5. 1 times 1 is a 1. And then 180. Because of a 2 decimal, I'm going to have 2 decimal places back. Okay? So in here, I have 1.8 x. Pretend we can have letter x for the question mark. After that, we have 472.59, which is copy it down. Now, just by a reverse calculation that we talked about before, I see the 90 that's hanging around. Let me go ahead and get rid of 90 by subtracting 90 on both sides. Okay, now plus 90, negative 90, now it's gone. Now in here, I left with 382.59. Okay, and then here is 1.8x. Oh, great. Then I have to go ahead and simply divide by 1.8 on both sides. Divide by 1.8. So I have 382.59 divide by 1.8. So in here, to be fair, we can actually move the decimal together, one place over. So I have 3825.9 and then divide by 1.8. Oh, sorry, 18. So let's take a look at this one. So how many 18 can I fit inside 38? If I fit 2 of them in there, 2 times 8, 36. Okay, great. So I can fit 2, 36 in there. Now we'll have 22. How many can fit in here? Oh, 1. Great job. I'm going to put in 18. I left with a 4 and a 5. Okay, how many can I fit in there? Let's try 3. 3 times 8 is a 4, and then it's going to be 54. That actually doesn't work that well. So let me go ahead and plug in the 2 again. So let me plug in the 2. Just like the first one, I'm going to have 36. Oh, what's left? I have a 9. Okay, great. Now the decimal comes in. I have a 9 again. So put in decimal. Well, how many 18 can I fit inside 99? Well, I can calculate that, but I don't have to because 212 already show up right here. So that means if I have a distinct answer at the very beginning, then I don't have to finish calculating all of that. Okay, so that is how we find out this answer. The most important thing right here is actually setting up the equation. According to the English sentence, she is saving up for the balance with the 15% of each week, and there's 12 weeks just passed. So that's how we are setting up this equation and solve for it. Let's take a look at number 76. Now in here I have this. This is a ratio problem. It says, what is the value of x for proportions shown above? So in here I'm going to have a few different methods. Number one, we can rewrite it. We have x over 35 is going to be equal to 20 over 28. First thing, based on this, I can actually do a cross multiplication, right? I can have 28x equals, and then 20 times 35. Now, if you have to, you can have x equals to 20 times 35, and then divide by 28. Now, for me, I personally do prefer a simplification before any of the multiplication. Therefore, I can actually delete into 10. I can delete into 14. Well, I can keep evening out with the 2. Then I'm going to have a 7. Then I'm going to have a 5. Great. Oh, 35 and 7 can cancel out again. So actually, the answer is just 25. Now, actually, there's another way to solve this. 5x over 35 equals 20 over 28. Let's take a look. Is there any simplification between numbers? Well, I have this and this can both divide by 7, so let me go ahead and cancel that out. So that's going to be 5. It's going to be 4. Well, I realized that the 20 and the 4 can be canceled out again into a 5 and a 1. Well, hold on. And now after this, I can have a cross multiplication, which is 5 times 5 and x times 1, which is x, which is equal to 25. Regardless which one you do, you still have the answer for 25. Just like that. Okay, let's take a look at question number 77. Now here, this one is just a PEMDAS question again. This one is according to your order of operation. So in here, everything comes in parentheses, must be solved first. So I'm going to rewrite it. Oh, and here, this is going to be negative a squared. So in here, this is going to be what? A squared is 64. Again, negative negative becomes a positive. After that, this is going to be 9. This is going to be 4. We're going to solve that later. Now, again, everything inside parentheses come first. So 3 minus 8 plus 2. This is negative 5 plus 2. You have a negative 3 parentheses square. Now, based on that, this whole thing will become a 9 again. So in here, I have 9 plus 64 plus 4. And then divide by 9. Okay, let's merge them. So we have 9 plus 64 plus a 4. So we have a 68 plus a 9, and that is going to become a 77 divided by 9. Oh, and that is our answer. Ta-da! Just like that. And this one, there's no shortcut. This is just following the rule for PEMDAS. Question number 78. Let's take a look. A soccer coach purchased 15 pairs of cleats for the team members and spent it a total of $805.95. Now again, this is 15 pairs, and then this is going to be what it comes from, and then including tax. So we're not only just having the 15 pairs of material, but also the tax of it. So if the tax rate is 8%, which is very similar to New York's tax rate, what is the price of each pair of cleats before tax? Okay, so in here, this is going to be requiring us to remember how to calculate tax. We have 15 pairs of the amount of money that you spend on each one. And after that, the whole entire thing, you have to calculate with 1 plus 0.08. Why was that? 1 represent itself, and the 0.08 represent the tax. And why do I merge it immediately like that? Because we have seen this before on calculating coupons, calculating for tax. We can immediately merge with the 100%. And then it says this, the whole entire thing is going to be equal to 805.95. And then the question asks for what's the price for each pair. And then just now we already set it equal to x. So right now that's the moment for us to solve for this question to find out what's the letter x. Again, we're solving for it. That means we're trying to isolate that. Let's take a look. That means in here I have 805.95 and then equals 15x and then times 1.08. As we mentioned before, you can either do 15 times 1.08 first, or maybe you can get rid of it using 105.75. Again, in here today, we're not using calculators other than the whole entire chain calculation, so I'm going to try my best to practice on mental math solving. So in here, or maybe handwritten solving. So I have 1.08, and then because of the 2 decimal moving, I can move it to the right side. I'm going to have A0595 divide by 108 this time. Now, since 1 and A is actually having 8 difference, and I know that 8 times 7 is definitely more than 5, so I'm going to best try my answer as 7. 7 times 8, 56. 1 times 7 is 7, so I'm actually having a, 49 extra. Okay, so based on that, well, 49 doesn't fit 108, so I'm going to put a 9 over there again. Well, I know if I put a 5, it's not going to work. Let me try 4. Now, 4 is going to be 432. Okay, and now I'm left with 67. I'm going to move down a 5 because it doesn't fit for 67 for 108 with division, so I'm going to keep moving. Let's see. I'm going to have 6. Let's try it out. 6, and then 48. I'm left with 7 and a 2. Okay, now it comes in the decimal. Well, I can keep calculating, and I'm going to have, let's try 2. So we have 216. And then with that, I'm going to go ahead and have, let me put the dot bigger, so in case anything got confused, I'm going to have a 4, I'm going to have a 6. Well, actually, if I borrowed 1, I'm going to have a 54, sorry. With that, well, it's going to be very something similar. I'm going to have a 5. I think we're going to finish that because 5 times A is 40. And then finally, we finish the division. So in here, when I rewrite this is going to be 746.25 equal to 15x. Great. Now I have to get rid of 15. So 746.25 divided by 15. That's going to be a 4. And then I'm going to have a 60. And then 1, 4, 6. Let's go ahead and try 9. 135. Now I'm going to have 11, 2. Let me make sure the decimal's there. I'm going to have a, now in here, since the 49 already show up, that means this 2 is going to be either our answer. So that means my bet is either try 4 or a 7. Now again, constantly looking at your answer is going to be actually helping you for calculation. So in here, I guess that putting a 4 is going to be way too small because I got a 60. So I should try a 7. So 5 times 7 is 35. It's going to be 105. I left it at 75. Based on that, I have a 3 left only. Well, actually, he's more than 3. It's a 5, sorry. It's going to be 75 and a perfect division. So in here, I'm going to have F as my answer. But if you do have a calculator and they permit you using a calculator on specific questions, then you're allowed to use a calculator, just like that. Okay, we have very 2 long divisions, very, very long divisions. Let's take a look at the next one, number 79. Now, the numbers M, N, P, Q are different, and each is equal to one of the numbers. Now, all 4 of them is actually have to satisfy this condition. So based on that, we have to make sure that 4 number got plugged in and see what is a relationship. Now, there's one trick right here, and then they're looking for the value of P. And there are 5 different options for me to choose. That means, hold on, if I actually start from the smallest number, that means all I got to do is just test on 2. Why was that saying that? Let's take a look. Now, the more that you times is going to be valuing the less. So the more that you times is going to be valuing the less. That means in here, if I actually rank this, Q is going to be the smallest, and then M is going to be the second smallest, and then it's going to be P, and it's going to be N. Because half of my N is already equal to 6 of the Q. So that means the bigger the coefficient, the smaller the value is. That's how a multiplication works, right? So based on that, I'm going to have small. Let me write this down. This is going from small all the way to value large. Okay, so that means Q definitely have to be either 1 or 2. So based on that, I'm just going to plug it in and see if that's going to work. So if I Q is going to be 1, so 6Q is going to be 6. And then what is 2M going to be? Well, that means this is 6 times 1, if I actually plug it in correctly. So 6 times 1 is 6. And then that means my 2 times something is going to be equal to 6. So M is going to be 3. And then if I have, 1/2 of n is going to be 6, so that means my 1/2 is going to be times the 12. And then p is going to be 6, so p salvages is 6. So I need to use the number 3, 1, 12, 6. Did I use everything? 3, 1, 12, 6. Oh, great! I actually did. So that means based on that, my p is a 6. Let's double check on the other one and see if I can actually solve for it. Now on the other one, I have to say that, oh, what if I try number 2? Let's try 2. If I have 6 times 2, that this whole entire thing becomes 12. That means 1/2 n will become a 24, and then we don't own the number of 24. So that means my first try is already correct, because n cannot be a 24. Let's take a look at number 80. Now here, this one is a very simple comparison number. This question says, if a person chooses a number at random from the set above, what is the probability that the number is less than 0.05? So that means we're going to say anything that's less than 0.05. First thing, this is at the third place. This is our 10, now 100, and 1,000. So this is a 1,000th place. So in here, we're going to go ahead and find this and compare and then find the one that's less than it. 10 place, not okay. 100 place, not okay. 1,000 place, great, but 1 is less than 5. Oh, that is correct. So this is going to be a good answer. Anything that is more digit, that's definitely going to be smaller. So I have a 3 out of 5 for less than 0.05. 0.005, sorry.